Hi everyone, this is Yuka and welcome to my home on YouTube. It's been a while since I've gotten around to recording any more videos, but hopefully I should be able to keep this going on from now onward. In this video, I intend to explore what kobjects are in the Linux kernel, and I will be learning with you, hopefully with the help of this documentation here and the source code that I've opened up, what kobjects are and how they are used within the Linux kernel. The documentation I'm looking at is the kernel documentation, and I can see that it's a bit dated, but I guess that is all we have to go on for now, because the other primary search result that I get is the one quoted over here, and it's supposed further older, from 2003. So without further ado, let's get into it. The idea is that we will read through the documentation here, and when in doubt, refer to the source on the left. Okay, so let's see. Based on an original article and located at this. Okay, so part of the difficulty in understanding the driver model and the kobject abstraction upon which it is built is that there is no obvious starting place. Okay, dealing with kobjects requires understanding a few types, all of which make reference to each other. Okay. In an attempt to make things easier, we'll take a multi-pass approach, starting with vague terms and adding details as we go. To that end, here are some quick definitions for some terms that we will be working with. Okay. The first one is a kobject. Okay, a kobject is an object of type struct kobject. Sounds good. Kobjects have a name and a reference count. Okay, it also has a parent pointer, allowing objects to be arranged into hierarchies, a specific type, and usually a representation in the sysfs virtual file system. Got it. So so far it makes sense, right? So something I had read up on before starting this video is that kobjects were originally introduced into the kernel as a reference counting mechanism. So it makes sense that every kobject would have a name and a reference counter embedded within it. However, it is interesting to know that there is a pointer within every kobject to its parent, and that it has a type. So perhaps so there would have to be at least one kobject type that does not have a parent. I assume its parent field would be set to null. Let's take a quick look at what struct kobject looks like. Okay. So we can find kobject inside include linux kobject.h. Okay, so as mentioned earlier, it has a name and it does have a reference counter. I believe that the reference counter is implemented using this kref over here. And we can see that the reference counter, let's take a really quick look at how the reference counter is implemented. Let's just jump to this definition. I seem to be having some problems with source insight. Let's see. Okay, so over here we can see that struct kref contains just one element called ref count, which is of type ref count underscore t, and ref count underscore t is an atomic t value named refs. Okay, so a peculiarity that I remember about atomic types is that you can only use certain specific functions to operate atomic types. This is the case so that the actual operation works in an atomic way. So for example, there will likely be functions like ref count increment, ref count decrement, and so on. We can take a look at that over here. We can see that there are functions like ref count add, ref count increment, ref count decrement, and test, and so on. So these are the functions that can be used to perform arithmetic operations on a ref count type. So we have a ref count type, and that is embedded, or that's effectively what a ref count underscore t type def is. That's effective. So because ref count underscore t is a type def, we can conclude that the structure ref count underscore struct is meant to be an opaque data type. That is, using this reference counter does not require knowledge that ref count underscore struct has a refs field inside it. Okay, and I guess that is why we have methods such as ref count read and so on implemented here. So if you look at the functions, you can see that it's sort of a nice wrapper around the atomic add of atomic underscore star functions. Cool. So this type def is probably for making the code clean. So we can go back to kobj, and we can see, okay, so we have a name and a reference. We see that there is a pointer to the parent. This was described earlier in the document. There is also a type, and there is also a pointer to a sysfs directory. So we can see here that the sysfs directory entry is denoted by a kernel-fs node pointer. That's interesting. So I guess it might be, I'm not sure, but it might be safe to say that whenever you see a kernel-fs underscore node pointer, you are effectively dealing with a reference to a sys directory in the Linux kernel. Out of curiosity, so kernel-fs node seems to be its own structure with quite a fields called count, parent, name, and so on. Okay, we will not dive into that right now, but it sort of makes sense why a node representing a directory in sysfs would have a parent field, because if it were sys-a, then I would assume that the node referring to A would have a parent set to a node referring to sys, and so on. So that makes sense. Yeah, cool. Let's get back to our notes here. K-objects are generally not interesting on their own. Instead, they are usually embedded within some other structure which contains the stuff that the code is really interested in. Sounds good. No structure should ever have more than one K-object embedded within it. If it does, the reference counting for the object is sure to be messed up and incorrect, and your code will be buggy. So do not do this. Okay, this is an interesting note, because if the intention of the K-object is to manage reference counts for an object that is used in multiple places across the kernel, and if the idea is to free this object when the reference count is 0, then yes, it does not make sense for any struct to embed two K objects within itself. Okay, that makes sense. Let's look at the next one. A ktype is the type of an object that embeds a kobject. I see. Okay. So every structure that embeds a kobject needs a corresponding ktype. Okay. The ktype controls what happens to the kobject when it's created and destroyed. Interesting. So if I understand correctly, suppose you have a structure of type struct A and you embed a kobject within that, then the kobject's ktype has to be set to type struct A. I'm not sure how it will denote the type information in memory, but that is sort of what this line seems to suggest. Let's take a quick look at the source here. We see that the ktype is of type struct kobj type pointer, and kobj type seems to have no references to it, which is a bit strange. Let's take a look. Kobj type. Interesting. I'm going to this might be a problem with source insight or how I'm using it, so I will use Elixir to search for information. Let's go to the latest version and let's look for kobj type. Okay, so kobj type is inside kobject.h, and this file is it kobject.h? I would assume, yes, this is kobject.h. So interesting. So it says that it's in this very file. I'm not sure why source insight does not find this. Kobj type. Okay. Here it is. Not too sure why. Anyway, let's see what we have here. So kobj type has a function pointer called release. It has a pointer to sysfs ops. It has something called a struct attribute. I'm not too sure what that is. It's a pointer to a pointer. And it also has a kobj ns type operations field. I'm not sure what that is either. So at this point, unfortunately, I don't understand what most of the fields inside a kobj type is. Hopefully, as we proceed with the document, this will become clearer to us. But so far from the document, what we understand is that ktype is supposed to somehow refer to the type of the structure that embeds the kobject. Okay, so what do we have next? The next is a kset. And a kset is a group of kobjects. These kobjects can be of the same ktype or belong to different ktypes. Okay. The kset is the basic container type for collections of kobjects. Okay. Ksets contain their own kobjects, but you can safely ignore that implementation detail as long as kset core code handles this kobject automatically. At this point, I'm not too clear about what a kset is either, except that it is a collection of kobjects of which the constituent kobjects need not be of the same ktype. And that's all I understand from this paragraph. We can take a quick look at kset to see what the type is. Okay, so it has a list head list, which suggests that kset is part of a doubly linked list. Struct list head list denotes that it is part of a linked list. If you're interested in knowing more about the Linux kernel implementation of linked list, I would suggest you look at list.h within include, I believe. Include Linux, is it list.h? Yes, list.h. If you look at this file here, you can, it's a very interesting implementation of a linked list. It's meant to be reusable across the entire Linux kernel, and yeah. What else do we have? We have a spinlock, which is a member of the kset struct. And if I remember correctly, a spinlock is meant for busy waiting. That is, a process that acquires a spinlock should not go to sleep or call any functions that would cause the thread to go to sleep. For example, kmalloc with certain flags would cause the kernel thread to go to sleep. Calling schedule would cause the kernel thread to go to sleep. If you acquire a spinlock, then you are not supposed to go to sleep. Additionally, the critical section that a spinlock guards is supposed to be very small in size. So I believe those are the characteristics of using a spinlock. And the kset has one instance of a kobject. Interesting. I would have expected a pointer or a list of kobjects, but it seems that a kobject has exactly one. A kset has exactly one kobject. Perhaps the kset has one kobject, and from there on it's arranged in a hierarchical fashion of some sort. Otherwise, I don't see how a kset can be a collection of kobjects. There is also a const pointer of type struct kset uEvent ops. I'm not sure what that is either. Curiously, there's something called randomize layout. I wonder what that is. Let's do a quick search to see what the randomize layout is. Interesting. So looking around for what randomize layout is, we come across this one post which talks about struct layout randomization, and I wonder if this is in some way related to KASLR, which is the kernel address space layout randomization. So I'll have a quick read of this. This plugin randomizes the layout of certain structures at compile time as a probabilistic defense against attacks that need to know the layout of structures within the kernel. I see. While less useful for distribution kernels, it has still some value there, since now all kernel builds will need to be tracked by an attacker. Interesting. So if I understand correctly, the items within a struct are juggled around at compile time so that the list may not always be at offset 0 after compilation, or the kobject may not always be at the offset as the source indicates. Very interesting. So the plugin selects structures in two ways: manually marked with the randomized layout annotation, or automatically when a structure is found to consist entirely of function pointers. when a structure is found to consist entirely of function pointers. Very nice. Very, very nice. So I believe that I wonder if many of the underscore ops function table pointers will be randomized with this. According to the comment in this document, it will be, and that's great. Okay, so let's get back to our documentation. When you see a sysfs directory full of other directories, generally each of those directories corresponds to a kobject in the same kset. Yes, that makes sense. Yes. This is what I was describing earlier. If there is a /sys/a, there is probably a kobject corresponding to the a, kobject corresponding to sys, and the kobject corresponding to a has its parent set to kobject of sys. Or that's how I assume it to be at this point in time. We will look at how to create and manipulate all of these types. A bottom-up approach will be taken, so we'll go back to kobjects. Cool. So that's it for this video. I will make more videos on the rest of the article. I just think it's a good idea to split this up into different chunks to reduce viewer fatigue. Okay, if you like this video, please subscribe and like it. Hope to see you for the next video.